All right, so this says you measure 30 randomly selected textbooks weights and find they have a mean weight of 32 ounces, and assume the population standard deviation is 7.1. Based on this, construct a 90% confidence interval for the true population mean weight. So we know sigma. So when we do this, this is going to be a z interval. So when I go to my calculator, let me pull that up. We're going to do stat tests a z interval. We're going to input statistics. So the sigma is 7.1 because that's the population standard deviation. Our mean from our sample is 32. Size of the sample is 30, and we want a 90% confidence interval. So 0.90. So we get 29.87 to 34.13. Uh, 34.13, sorry. Right. That's it. Since we know sigma, we got to use the z interval. And then 55 says a market researcher wants to evaluate the car insurance savings at a competing company. Based on past studies, he's assuming that the standard deviation of savings is 100. He wants to collect data in such that he can get a margin of error no more than $10 at a 95% confidence level. How large of a sample should he collect? So the first thing we want to figure out is the standard deviation of the population is 100. So we know sigma. So we're talking about using the z interval. So from our course materials, we have this formula for finding the sample size for estimating a population mean. This is the Chapter 8 PowerPoint notes, slide 29. So we're just going to copy this formula over to our smartboard real quick and just pull out all the necessary information. So we're looking for n. We're looking for a z-score that cuts off the middle 95%. So if I draw my z curve, I'm looking for the z values that cut off the middle 95, which means there's 0.25 on either side. 0.025, sorry, 0.025. So that z value, if I use inverse normal, I'm going to find the area to the left of this, which is 0.975. Mu is 0, sigma is 1. So my z value is 1.96. Sigma is 100. Margin of error is 10. So I can just plug everything in. My n is going to be 1.96 times 100 divided by 10. That whole thing squared. So I'll just take that number times 100 divided by 10 and square that whole thing. So now, even though if you're looking at this number, rounding it to the nearest whole number would be 384, since we want to make sure that our sample is in fact large enough, rounding down might make it too small. So when you have a probability, no matter what the decimal is, we're always going to round up. So this is going to be 385 people. Make sure that if you don't know sigma, you use the correct formula from the notes, as well as if you're talking about a proportion, the formula is different as well. But they're all located in that PowerPoint.